So rational numbers, the definition of rational numbers is the set of all, so this is Q, which is the notation for rational numbers. So anything that looks like a P over Q, and the important thing is both P and Q are integers. And let me remind you what integers are. The set of integers is 0. It includes 0. It could be plus or minus 1, plus or minus 2, plus or minus 3, and the list goes on forever. So if you have any of these numbers in the numerator, let's say we have a negative 3 over, and let's say 4, positive 4. So this is the fraction, negative 3 over 4. This is called a rational number. Any number that can be put in the form of a fraction, like a P over a Q, where P is an integer. Integer could be any one of these numbers. It's a positive or a negative whole number. So that would be a rational number. Now let's think about quick examples. Suppose I have 7. Is that a rational number? The answer is yes. I can put it in the form positive 7 over positive 1. Both 7 and 1 are integers. It could also be written as, it can be written in infinitely many ways. I'm just giving you a few examples. Both negative makes a positive, so negative 7 over negative 1. Or it could be, let's say, 49 over 7, which is the same as 7, because 49 is 7 times 7 over 7. So anything that can be written in this form is a rational number. Now, what about 0? 0 can be written as 0 over positive 5. For example, it can be written in so many different ways. So P over Q. P is an integer, Q is an integer, therefore it's an integer. Now, what about any whole number? 3. 3 can be written as, let's say, 9 over 3. That's a 3. It could be written as negative 9 over negative 3. It could be written as negative 3 over negative 1, and the list goes on and on. So anything, any number that can be written as a whole number over whole number, both positive or negative, which makes it an integer, is a rational number. And we've done this before. Now let's see what rational functions are. So this is an extension of that idea, and now we're going to not think about integers and numbers, whole numbers. We're going to think about algebraic expressions. Now anything in the form P over Q, and what's the important thing here? You cannot have Q, the denominator cannot be equal to 0, and this is important. Just remember this. The denominator is never equal to 0. Never ever can the denominator be equal to 0. The expression or the function or the number is undefined when the denominator is 0. Now let's see what rational functions are. Now you've seen what polynomial functions are. Polynomials, let me give you some examples. P of x can be written as 2x plus 1. What are the conditions for this to be a polynomial? This can be any real number. It doesn't have to be a whole number. It could be a decimal, it could be a radical expression, it could be a fraction, anything. But the important thing is to look at the x's. The exponent has to be a whole number. It cannot be negative. So for example, if I say k of x equals 3x to the negative 4 plus 1. Now that is not a polynomial function. It's some sort of a function, but it's not polynomial. So what's the condition? For polynomials, the exponent has to be a whole number. So let's look at a few quick examples. Let's say P of x equals radical 2 x to the 7 minus 2/3 x to the 5th plus 0.25. Is this a polynomial? First check. all the coefficients, these are numbers multiplied to the x's, are called coefficients, and this is called the constant. All are real numbers. Any form, it's fine. What's the next important thing to check? Check if the exponents are whole numbers. It has to be positive. Okay, that makes it a polynomial. So what does a rational function look like? Or a rational expression? There's a difference between a function and an expression. So let's write down an expression. 3x minus 7 over 1 minus x. Is the numerator a polynomial? The answer is yes, because the exponent is a 1. The exponent here is a 1. It's a whole number, positive, and therefore each is a polynomial. So a polynomial over a polynomial is a rational function. Let's look at more examples. If I have 3x squared plus 1 over x cubed minus 2x plus radical 2, is this a rational expression? We're looking at expressions first. We'll think about functions a little later. So the answer is yes. Look at the exponents on x. All whole numbers, that's a 1, right? If there's nothing, that means it's a 1. And of course, you have all the numbers which are real numbers in some form or the other. So this is another example of a rational function. So the first question is evaluate the expression. Evaluate means find the value, which means you plug in the numbers that are given and find the value. So first let's plug in the first number, x equals. So for each, we'd have to evaluate the expression. So all you have to do is plug in the number. Wherever you see an x, so you see an x here, plug in x equals negative 2. Plus 2 divided by, you see another x here, plug in negative 2. And then you have a plus 3. Now simplify it. Negative 2 plus 2, opposites cancel each other to get a 0. And 3 minus 2 is equal to positive 1. 0 divided by any non-zero number equals 0. So the 0 in the denominator is perfectly fine. Now let's plug in x equals 3 in the same expression. So let's plug in x equals 3. So in the same problem, plus 2 divided by, wherever you see an x, plug in a 3, and then you have a plus 3. So that is equal to 3 plus 2 is 5 over 3 plus 3 is 6. So what we were given is a rational expression, a polynomial in the numerator, a polynomial in the denominator. What we're doing here is evaluating the expression, which means plug in the numbers and find the value. So here we plugged in x equals 3 and you get 6. So when you plug in x equals 3, you get 5 over 6. And when you plug in an x equals negative 2, you get a 0. Let's do the same thing here. Let's evaluate the expression. Let's do x equals negative 2 first. So you see an x squared. So we do negative 2. Put it in parentheses because even the negative has to be squared. Divided by negative 2 the whole squared plus 4. We simplify the expression. So you get 4 because negative squared is positive. So it's positive 2 squared, which is 4, divided by 4 plus 4. Simplify the numerator because it's addition. There's no cancellation. 4 plus 4 is 8. When you simplify, you get 4 times 1 over 4 times 2. The 4's cancel and it's equal to half. Now let's do the same thing by plugging in an x equals 3. So wherever you see an x, so it's x squared over x squared plus 4. So we go 3 squared. 3 is a positive number, so the parentheses don't make a big difference. If it's negative, makes a big difference. Plus 4. So that's equal to 3 3s are 9. 3 squared is 3 times 3 over 9 plus 4. And that's equal to 9 over 13. Let's look at this rational expression again. It's a polynomial over a polynomial. So it's called a rational expression. It's not an equation, so it's just called an expression. So let's plug in x equals negative 3. So you get negative 3. Wherever you see an x, plug in a negative 3 plus 2 over, in the denominator, negative 3 plus 3. So this is equal to negative 1. Negative 3 plus 2 is negative 1 over 0. Now, if you remember, the 0 in the denominator tells us that this expression cannot be evaluated at x equals negative 3. So at x equals negative 3, the expression is undefined. So when is it undefined? When one of the ways in which it can be undefined is when there's a 0 in the denominator.